Welcome to an overview of the AI agents revolution and its strategic implications for enterprise autonomy. In this presentation, we will explore how modular agent designs, emergent workflows, and memory systems enable intelligent, long-running processes. The title slide sets the stage, and the illustration hints at interconnected components working together to transform decision-making and operational efficiency. This slide outlines a core AI agent architecture where perception modules feed an LLM-powered reasoning engine connected to short and long-term memory banks and executable tools. The diagram shows a feedback loop for self-correction so agents can adapt over time. Think of this as a modular pipeline that integrates sensing, memory, reasoning, and action to pursue dynamic goals. Here we walk through a single agent autonomous loop that senses state, generates a thought, selects an action, observes the resulting state, and stores experience for future cycles. The visual highlights iterative refinement through reflection prompts and experience updates, which improve subsequent decisions. This mechanism enables tasks like autonomous web research, code generation, and data analysis in a closed learning loop. This slide describes specialized agent swarms that collaborate via a shared message bus with role separation across planner, coder, tester, and reviewer agents. The graphic illustrates parallel execution and message exchanges that orchestrate complex workflows, enabling higher quality outputs and faster throughput. By assigning distinct responsibilities and enforcing review loops, teams can scale development and scientific experimentation more reliably. Grounding reasoning with function calling turns abstract model outputs into structured JSON calls that trigger external tools like search APIs, calculators, and databases. The flowchart shows how function descriptions become actionable requests which retrieve real-time data or perform computations, producing grounded results beyond static text and enabling timely, verifiable decisions for downstream tasks. Secure runtime and iterative feedback protect execution while enabling debugging and improvement. The slide shows an agent-generated script running inside a containerized interpreter within a safe runtime, with stout and error streams feeding observations back for refinement. This pattern isolates execution risk, supports iterative debugging, and allows safe data processing and visualization without exposing host systems. Memory architecture balances short-term context with long-term retention using hybrid retrieval to influence decisions. Short-term memory preserves conversational and task context within token limits, while long-term storage uses vector databases and file stores to retain facts, preferences, and logs. The combined approach ensures relevant historical information informs decision and action over time. Reflective memory and progressive skill acquisition turn past actions into distilled insights that guide future planning. The diagram shows critique and condensation of past outcomes into reflective memories, which then inform progressive skill growth and better handling of open-ended tasks. This reflective loop reduces repeated mistakes, accumulates competence, and improves adaptability in complex scenarios. An autonomous research workflow automates literature review and market analysis through a continuous learning loop of data acquisition, knowledge extraction, and iterative gap analysis. The flowchart highlights crawling and ingestion, semantic synthesis, and refinement cycles that produce structured strategic outputs like reports and analyst-level insights. These outputs support enterprise decision-making with unattended overnight operation. Developer agent teams automate the software development lifecycle by turning product requirements and user stories into generated code, unit tests, bug fixes, and documentation. The central developer agent core coordinates autonomous pull request creation and continuous integration hooks, producing accelerated MVP delivery and enterprise-ready prototypes. The visual emphasizes rapid prototyping and end-to-end pipeline automation. Future personal AI agents manage responsibilities like calendar, email, shopping, and learning goals while adapting through prolonged interaction and preference learning. The diagram suggests portable memory and cross-service APIs to avoid vendor lock-in and foster trustworthy companions. Over time, these agents become personalized digital companions that adapt behavior to user needs while preserving control and portability. Governance and safety frameworks ensure autonomous agents remain beneficial extensions of human intent by enforcing transparency logs, alignment audits, and emergency kill switches. The slide links regulated tool access, data privacy protections, and decision accountability to larger societal aims like safety and beneficial innovation. Robust governance balances innovation with control so agents operate transparently and in alignment with human values.